In this session, let's look at work rate and time problems in the GMAT exam, the problem solving question types. These are questions which basically fall under the algebra, but they are mainly presented as word problems. So they could fall, or they could overlap on either side of those questions, depending on how one would want to target them. That will be it. And before we get to the questions, the main thing that maybe I would want to say is these questions, they're not that many, but the weight they do have also depends on the difficulty which you are at. And nonetheless, also you will need to be able to get each problem at the unit time values to be able to solve what will be required of you. So that depending on what the questions have, the basic approach to these questions is that present the questions to the basic unit time portion of work done, then work your way to what the question asks you to. So without further ado, let's get to the first question. In the first question, we're going to look at the sub 600 level questions. These are questions which are pretty much direct to solve. They don't require much, and many students do get them easily. So you could pause the video, attempt this question, then come back and we can attempt it together. So the question asks, if you take one machine 10 minutes to fill a large production order and another machine 12 minutes to fill the same order, how many minutes will it take both machines working together at their respective rates to fill the order? So that's what you've been asked. So we're being asked if these two are working together independently, they take 10 minutes and 12 minutes respectively. So let's call one of them, let's call A takes 10 minutes. Then now B takes 12 minutes. Then we're being asked how long they take together. So to get these questions, how much work is done per unit time? Let's say not per minute by each of them. So in 1 minute, A does a tenth of the work, and then B does a 12th the work. So together in 1 minute, how much do? They do a 10th plus a 12th. That's what they do in 1 minute. What does this come to? I get the LCM to be about 60. So it will be 6 plus 5. So we'll get 65 times, so that is 5. So 11 out of 60 is a proportion of work done together in 1 minute. So in 1 minute, they'll do 11 out of 60, the work done. So how long will it take to do the whole amount of work, which is now like 60 out of 60? So to get to this other side, you just find the reciprocal of what can be done in a minute. So that's 60 divided by 11. That will be 5. And remainder will be 5 out of 11 minutes. Yeah. That is answer choice C. And there you have your answer. Pretty much straightforward. Doesn't take much of thought process to it, and you are home and dry. Now, the next question also is a sub 600. It's a bit tricky, but still falls in this category. Can pause the video, attempt this question, then you can come back and see how we approach it together. Circular gears P and Q start rotating at the same time at constant speeds. Gear P makes 10 revolutions per minute and gear Q makes 40 revolutions per minute. How many seconds after the gears start rotating will gear Q have made exactly 6 revolutions more than gear P? So here, let's say you have P, which makes 10 R per minute. Then you have Q, which makes 40 R per minute. So since you're being asked how many seconds after the gear starts rotating will Q have made exactly more. So let's find out how many revolutions are made per second, because being asked about seconds. So remember converting them to unit time. The unit time here is, in this case, is seconds. So it will be 10 out of 60 R per minute per second. This will be 40 out of 60 R per second. That is what we're being asked. So now that you have the unit time, the question asks, how many seconds after the gears start rotating will gear Q have made exactly 6 more revolutions than gear P? So that means gear P will have made plus 6 to be equal to what Q have made. Yeah, P plus 6. So we can call this the time taken to be like the time taken by P. So it takes, being asked in seconds, so we will find the time in T. Let's say call it T. So 10 out of 60, t in time, multiplied by the time actually it takes to rotate, plus 6 will be equal to 40 out of 60 revolutions times t, because it's the same time on both sides. This is 6 and this is t. So setting up the equation correct also sets you up for the answer. If you are not able to set up the equation, that is it. So what makes this question up be a bit tricky is being able to set up the equation the way it's supposed to be. So once you have it this way, now you can go ahead and solve for the answer. So we can actually collect the like terms together and have the t on one side and 60 and 6 on one side, so we can have it. So that means we'll have 6 equals to 40 out of 60 t minus 10 out of 60 t. So this will give us 30 out of 60 t is equal to 6. So this will come to a half. So t equals to 6 times 2, which is equal to 12. So t in seconds is 12 seconds because they're both in seconds. So after 12 seconds, then P will have made, P will have made 6 more revolutions than actually Q should have made. So 12 is the answer, and such as D.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Now let's go a notch higher and look at questions in the 600 to 700 level category. These are questions which require a bit more logic for you on the student side to be able to solve. And quite a number of students, unless they are able to put those in place, they are able to solve this kind of questions. So pause the video and also attempt this question, then come back and watch it as I tackle it. We have 6 machines at a factory operating the same constant rate. If 4 machines, four of these machines operating simultaneously take 27 hours to fill a certain production order, how many fewer hours does it take all 6 machines operating simultaneously to fill the same production order? So we're trying to see, we have 4 operating, they take 27 hours. If you have 6 operating, how many less hours will they take? It's because if you have more machines, then it will take less time. So first of all, we need to see how much is done by the 4 machines at a unit time. Also, probably now, what proportion, how can you express this in terms of the work done? So it's setting up an equation, and then you'll be able to use that to solve the equation. So 4 machines, they take actually 27 hours. So with 27 hours, 27 hours, that's what they take to finish the whole work. So let's see. One machine, how much work does it do in 1 hour? We don't know. So let's say it's X. So let's say one machine does 1 over X of the work in 1 hour. So therefore, 4 machines will do 4 times what a machine does. So 4 machines will do 4 out of X, the work, in 1 hour. Since it's taking 27 hours to do the whole work, then it does the whole work and presented by 4 out of X times 27 is equal to the work that you done now, the whole work, which is 4 times 27 out of X divided by X. So we may just hold it at there. I don't need to divide it fast because we need to find how many fewer hours. So maybe we'll see if we can be able to solve that later. Let's not focus on this now. So the same logic that you do have. If you have 6 machines, how much work will they do? They will do 6 out of X of the work in 1 hour. The whole work, how long will it take them? We don't know the time. Yeah, we don't know the time. So maybe let's call it T times T. But this one will be equivalent to the amount of work done by 4 machines. So it will be equal to 4 times 27 divided by X. So we can therefore solve for T in this case and actually know how long it takes. 6 machines to be able to finish the same amount of work that is finished by the 4 machines. So T will be equal to 4 times 27 over X times X over 6. So X cancels out. So we need to multiply that earlier on. And what do we have? 6 will go here, although 3 will go here 2 times, 3 will go here 9 times, 2 will go here once, 2 will go here twice. So 2 times 9 is actually 18 hours. So the 6 machine takes 18 hours to complete the work. 4 machines take 27 hours to complete the work. So how many fewer hours does it take? So we have 27 minus 18 equal to 9 hours, which is answer choice A. So it will take actually 9 fewer hours. So you see the trick is in all about being able to set up the equation correctly. Try to reason out your answer, your logic, to have your equation, to have actually your equation set up and known what is the known, what is the unknown, and how to solve for it, and how to reason them out. That's what we're looking at. Let's look at the last question. This last question is say that we have 2 water pumps working simultaneously at the respective constant rates. They took exactly 4 hours to fill a certain swimming pool. If the constant rate of one pump is 1.5 times the certain rate, the constant rate of the other, how many hours would it have taken the first pump to fill the pool if it had worked alone at its constant rate? Looking at this question, this actually, I would range it to the level of, let's say, 650 to 700. The previous question, 600, 650 difficulty level, because this is a bit more tricky to set up. But nonetheless, with the same concepts that we have, and actually working our way backwards, apply the logic to each question, we can be able to fill this question. To be able to answer this question. So let's see. We have these 2 pumps working together, fill a pool. One is faster, they're no longer at constant rates. The previous question, it was actually both of them were at constant rates, but these are now, they are at different rates. So what happens if you have different rates? So let's see, it takes 4 hours to do the whole work. So the whole work, yeah. So the work. Therefore, in 1 hour, they'll have done what? A quarter of the work. So you need to know how much work is done by each pump in 1 hour. That is what you need to know, given the proportion that you do have. So it's still demystifying them and reducing them to the basic unit times. So we have one, let's say one is X, so the slower pump is X. Then faster is actually 1.5x. Yeah. So if you have both of them working together, then actually they'll end up doing a quarter of the work. So let's find the rates actually for each of them. Let's say X plus 1.5x. The 2 rates work together does a quarter of the work. So I want to find the rates of each of the pumps. So what's the rate of the slower pump? Then I can get the faster pump's rate. So it will be 2.5x is equal to a quarter. Let's convert this into fractions that now we can be able to work with them from the same number type. So 2.2.5 is equivalent to 5 over 2 is equal to 1 over 4. So x could be equal to 1 over 4 times 2 over 5. So this actually will get to 1 and then 2. So you have actually 1 over 10. That is the rate of the slower pump. The faster pump, 1.5x, is equal to 1 over 10 times 1.5, which is equal to 3 over 2. Is equal to 3 out of 20. That is the rate for each of them. So the rate of the slower pump is 1/10 of the work done in 1 hour. The faster pump does 3 out of 20 of the work. So therefore, if actually it was working alone, how many hours would it take the faster pump to fill in the pool? The faster pump, that is this second one. So 3 over 20 is in 1 hour. How about the whole 20 out of 20? That will be the reciprocal of this, that is 20 out of 3. will give you 6 and 2 over 3. And then from the answer, you usually have 20 over 3. So that is it. So 20 over 3 is the correct answer. And that is how we do approach these questions. So it's all about converting them into the unit times, finding a logic around them, and then using that knowledge that you have acquired, go to the next steps and getting your answer. And you can do so that it can be done in the shortest time possible. So thank you once again for watching this video, and I'll come back again next time when I'll be covering more on different topics. Bye.